Hey, my name's Ben Odom. I'm a developer evangelist for Intel Corporation, mostly around HTML5 and Android. And I'm here today to take you on, share a little bit about my journey and experience with the Internet of Things. I realize I might have jumped on the bandwagon late, but I guess I'm a product of my environment. There's always plenty of hardware around Intel, and I spent the last 18 months in 2012 and 2011 hardware accelerating Flash and Air on Intel phones and tablets. So that obviously went awry, and I had to switch ponies to different web technologies. So I don't know how many of you caught the keynote this morning, but we go to a lot of these shows, and we always get two questions like, Intel does software, and why does Intel care about HTML5? And I figured I'd just kind of address those things today. So Intel loves an open environment so that people can create, interact, build, share, create something that goes from device to device, whether it be a phone, a tablet, a TV, a car, all of it. We play in all of those spaces. The bigger the environment, the better we are. We like HTML5 because it's open. It means we can contribute. It means we can compete on platform and differentiate and build the best possible product for you to uniquely take advantage of and differentiate your product. And of course, I think as you saw today, we launched a new tool today, the Intel XDK new, which I'll get to later. But we do a lot of support in the community, whether it be through W3C, standards, tools, open source contribution, a lot of efforts all over the place. Something that wasn't highlighted into you today is, where is Intel actively involved? We actually lead several of the working groups, near field communication, automotive. We're heavy contributors to security, audio, and then also pretty heavy web application contributor to these working groups. So we spend quite a bit of time in the W3C. Our latest efforts, Miracast or WiDi, which will allow you to basically think of like a console where you can have all your controls on, say, a phone and what you're actually looking at up on the screen, doing two-screen differentiation on IA products. But enough of that. Let's talk about why I'm here. And my inspiration for this is I went to Web Visions earlier this year, and it's a conference. It's held in Portland and in Barcelona. And Mark Fornhofer, who's I think one of the founders of Boing Boing, had the keynote. And he was talking about the Internet of Things, and it kind of woke me up. And he showed us a picture of this 13-year-old maker, and talked about him for a few minutes, and it was pretty inspiring. I was like, oh, that's awesome. It's something I think I'd like to teach my kid. And this is, of course, what a 12-year-old maker makes. Any guesses on what this might do? So it's an Arduino and a methane detector, and what it did is it tweeted every time it detected a fart. Which is exactly what you make when you're 12 years old, right? So anyways, I was like, oh, that's interesting, and I gotta check this out. So it was quite the learning experience diving into the world of Arduino, and you think you could run down to any website and get an Arduino that's reliable, and let me tell you, many Arduino components, while they might look the same, are not the same. You'll see anywhere from a 2-layer to an 8-layer board, and when you're pushing on it, bending it, soldering on it, you want that really thick, nice layer, heavy board. Another crazy thing is the parts all look very similar, but it's really worth your effort to check the exact model number and see if you can see spec sheets and see if there's any reference code for the sensors. It totally helps you debug and test and be able to electrically verify what's going on, because a lot of it's high bytes and low bytes, and you need to know the voltage levels there and make sure that they actually do that. I have 2 sensors that haven't arrived from China, so try and buy them locally in the United States, Canada, somewhere if you can. I got one, and I'm waiting for one more. And definitely, you're going to blow stuff up if you're playing a lot. So buy multiple items. It kind of hurts, but always have 2. It's kind of cool. So what does it take to get started? Arguably just this, an Arduino. You can plug it into your laptop and you can make the LED on it blink in patterns or whatnot. But I kind of went deluxe, and this is a kit from Adafruit, who's my favorite supplier for a lot of this stuff. And for 80 bucks, you kind of get the full blinky light push sensor kit to get yourself started. It's a great way to get going, and it comes with an experimenter guide. So it walks you through about 10 lessons, which gets you familiar with Arduino and maybe refreshes your C if some of you haven't programmed in C before. Kind of helps you out with that. So once you master the blinky lights, it's kind of all about sensors, and that's where you can start spending some money. And the Arduino and the LEDs are pretty inexpensive, but the sensors can start to add up. So this is the Ethernet shield. It's about 45 bucks. This is a luminosity sensor, a nicer one. It's about 12. This is the temperature and humidity sensor that I use. It's about, I think, 14 or something like that. And this is the really expensive component I use, which is a CO2 detector. And part of my whole point of this project is I'm convinced we live in a dirty building. And I kind of wanted to prove that our air quality was bad. And that's why people, so if you've ever been to an Intel facility, maybe you saw the Conan O'Brien thing. I mean, it's this room plus that room plus that room plus that room, just people. And we all go down sick at the same time. So this is a CO2 detector, and that was 60 bucks. And the most expensive thing I bought, and I only bought one, which kind of made me nervous, but that's what I did. You might also need a really good one of these. You have to do some very fine pitch soldering, and having a digital soldering iron that matched to your solder helps quite a bit. And of course, you're going to need one of these, right, to figure out what the heck's going on. So putting it all together, you want to try everything individually rather than at once. Here's just an example of me doing a really crappy soldering job. It took me about 2 hours to diagnose that I had overlapped some traces there. Triple check your wiring. It gets pretty crazy once you really start adding everything together, and you definitely want to do that before you power on, because this is how you blow up components. If you have things crossed, you don't have pull down resistors in the right place, things like that. And once you have it, do it one at a time. Try test sketches, and I'll show you a little bit like what a test sketch is. It's basically a reference code, if it exists, that you can run, and it'll just basically exercise the sensor. And then once you have it all together and make sure everything's sound, you're good to go. This is what's going on. So now you're finally into the code part, and one of the things I really was surprised at how much it mattered is the order that you initialize your sensors. Many sensors have methods that call into includes and header libraries, and those header libraries vary tremendously in size. Some are pretty small and quick, but others are quite large, and if you go reading through them, you'll see they have like delays put in them for taking the time for the hardware to set up. And so, the Arduino is pretty slow, believe it or not. I think it's like 8 megahertz or something like that. So you want to give it time to initialize, and basically what you want to do is you want to make sure that everybody's on the slowest initialization loop. So if you've got something in there that takes 2 seconds to initialize, that's as fast as you can initialize your entire device. So, and also you want to go cruising through your header files to understand the options that are available to you. That DHT sensor, if you look at it, a ton of people are like, it only outputs Celsius, and really if you go looking, there's one variable in there. If you set from false to true, it'll output Fahrenheit, which, what we all care about. Well, some of us, anyways. Pretty interesting. So set up the slower, bigger libraries first, and then in the void loop, which is basically your main while loop that runs on the Arduino, everybody runs at the same beat rate, and that will help with conflicts and timing. 32K. And you got to count every byte because it really does matter. My first computer, I'm going to date myself here, was a Commodore 64. It had twice as much memory as this. So I had, if you count the components, you got the Arduino, the Ethernet shield, the 4 sensors, and I had 826 bytes left for variables. So probably could have squeezed in one more component. You're pretty much forced to use these includes. But the nice thing is the Adafruit sensor libraries here are pretty common across a lot of the I2C type sensors, so you should be able to load up a bunch more and not expand your memory space. It's pretty awesome. I haven't had to do this since like grad school, get something so perfectly tiny in C that, basically taking out comments and everything else just to get your code space down as little as possible really mattered. It was kind of fun. So once you have everything up together, it's time to share your data, right? And you got multiple options. You can do an LCD screen. I enthusiastically bought that little color one you saw, but it takes 5 pins, and there's only a certain number of pins you have left, 13 digital and 5 analog, to drive all your sensors, and I ran out, so I couldn't drive the screen. So that's why I had the Ethernet shield. So that basically means, you're going to do something out your Ethernet port, which is what most people want every I'm going to show you what that might look like if you guys bear with me here. Here's the world's most simple Ethernet server. And if you can believe this, you're actually, you initialize the Ethernet client, and in this case, you always want to do DHCP because, static IP, because DHCP takes more memory, and so you run out. And so you are actually printing to the client, the headers, the content type, what's going on, and then you're just calling your variables for your thing, and you get like, hello, this is Arduino, and it tells you the 5 sensor values, and that's it. Right? That's what you get. Sweet. So you get excited about that, and you show it to your coworkers. There's about this many of them sitting around me, and the thing immediately hangs, and you're like, oh, come on, what's going on here? So you get all excited, and the thing hangs, and you're like, what could it possibly be? You go through the code. This is so simple. Nothing's wrong. You look at it. You step through it in DevTools. There's nothing to go wrong. Well, what it actually is the Ethernet client can only handle 4 concurrent connections. And so if you're refreshing the data, say every 5 seconds, and 2 people connect, or 3 seconds, I think is what I was doing, you've hung it. You've exceeded your maximum number of connections, and your Arduino just goes, whoa. So you got to have a new plan. And you're thinking about what you actually wanted to accomplish. You definitely want to serve more than one person. You want the information to come out on a timely basis. Geez, you've got all of these sensors that update at 200 milliseconds or so. You want to serve multiple clients. And I didn't do it for this class, but MongoDB is in my future. I just learned about non-relational databases, and it looks like I might give databases another chance in my life. And so I thought, well, here's a really good chance to use WebSockets, right? Ajax WebSockets, load the page off the SD card, and give that a try. So I found this WebSocket on GitHub. I'm sure we all just have a browser open on GitHub. And after putting in, I only had 3% of memory left and 10 bytes. And that's a little narrow because if you make any changes, weirdnesses start to happen. So I implemented this web service, and I'm a little nervous about time, so I could show you the code using that. And I was going to hook it up to Heroku or Lively or Pachu, but I think that's how you pronounce it, just to do all my logging, create the graphs, create the gauges, etc. And they get pretty expensive because if you're updating every 2 seconds and you figure like Pusher gives you 100,000 free messages. That's basically 1 day of client. So if you had multiple people looking at it through a day, you could easily start to have to pay for this stuff. But I had another issue. I'm inside a massive corporation with a really effective firewall. So that pretty much cut me off at the knees. And as much as we tried everything, even to traverse our HTTP puts through the proxy and firewall, that didn't work out so good for us. And it's not even worth talking to IT. So if at first you don't succeed, Node.js to the rescue. I did a local install. I was actually very new to Node.js. Some younger coworkers told me about it. I got to admit that I did not think of that right away. It was very cool. It was, just a .exe local install. It simplified all of our networking. I actually have it all set up right here. And the best thing is you could easily see the server-side messages in the debug console on the browser. You could, see your JSON query being parsed. And the NPM package manager is fantastic. That's the Node package manager for giving you all the things that you might want. Let me just show you what the Node setup looked like, because it's kind of interesting. So this is all it took for server. Oh gosh. Hang on a second here. For the server.js, you just set up the broadcast IP. I used a couple of requirements. Q for promises, which is something that's really useful in Node for asynchronous communications. And basically what that allows you to do is sometimes sensors hiccup. And so you catch the error, but you make a promise that you're going to return that value, and it allows your server to continue processing data without crashing. And so once the promise is fulfilled, it updates, and it just kind of, it's almost like it says, I'm giving you a buy, but I make you a promise, I'm going to give you that thing. And actually, if you saw the class over there, the What's Up with Angular, they're starting to look at promises like in Q too. So it's a really good way for asynchronous communication. I actually set up a static web server in it. I'll show you that later, so that I'll get to that a little bit later. And then it's simply Socket.io was the solution I ultimately ended up going with for my WebSocket. And that was pretty much it. So you create your listener. You parse your JSON, and there's the promises. You can see kind of the error results happening there, where it's going down, which allows it to continue. And then you basically parse your JSON here, and then you can output that to clients, via whatever mechanism happens to be available, which is why I used Socket.io. To minimize network traffic, you don't want to be updating everything on the web, on the client. There's a ton of browsers out there. It was pretty entertaining to have like 10 of your coworkers with 10 different phones all come up to you, and none of their browsers behave the same. It was maddening. I had it all working on about 6 of them, and I went up to my boss, who has the new Galaxy S4, and he's like, it doesn't work. And I'm like, oh God. Of course, you show your manager at the very last second. So what's really cool about Socket.io is it's super simple to implement. It supports WebSockets first, then it falls back to Flash, then it goes back to AJAX long polling, and then you can even go all the way down to JSON P polling. And depending on the client, like even Android phones that use like built-in versus Chrome, you'll see different kinds of polling in the Node server's logs, which is helpful for keeping that going on. So I just can't espouse how happy I was with Node. It prevented me from being client limited because it's actually running on a better machine. You can pretty much do anything with the JSON tool. Did a great job doing static web serving, and I already showed you guys what was required in there. So after that much exploration, I've arrived at this. I can send data to active sockets. You can see that I give light, CO2, temperature, and humidity. And then you can see below the debug output saying, yeah, and that's in fact what you're outputting in your environmental data. And your software architecture essentially looks like this, which is, after all of that, it's pretty simple, but it was pretty maddening to do all of that. So I'm set, I'm done, I'm good, right? Well, not really. I mean, data is all about visualization, so you want to do something cool. So I finally get to the HTML5 part of this conversation, at least the client side, not so much the server side. So we were looking for, to use HTML5, accelerate on the canvas as possible, be visually appealing, be a responsive solution, be responsive in updating, right? So have the ability to update pretty quick. And then be both a web app and a hybrid app so they can run across any platform, right? Not be limited. And I really like the web app, hybrid app combination because debugging in a web app is much quicker than it is debugging and building an application. So it's a really good way to figure it out. So we wanted some gauges. There's some really cool pay-for ones out there. Internally, we actually use Fusion charts for our business analytics on software.intel.com. It's a great product, but it's pretty spendy. HTML5 gauges is pretty awesome, so is Perfect Widgets. But I wanted an open source solution. MIT Apache license, something like that. So two favorites emerged, JustGage and then Canvas Gauge. Both have nice licenses and both are very attractive. But I ultimately settled on JustGage. I loved SVGA. I think vector graphics are the way to go when it comes to responsiveness. Customization was inclusive and pretty easy to do. The MIT license allows a big company like Intel to work with it. And I kind of like the modern flat style. And the author is actually pretty responsive. And what's really cool about this is because I work in the developer product organization, I actually had the gauge thrown into our new XDK as a widget. So you guys now have access to this product, and we've saved you a ton of work. You can, and I'll show you this later, you can actually use this yourselves, and I'll have to set this up. Here, let me show you what Gauge.js looks like. So Gauge.js is SVGA, which you don't even need to look at. It's done for you. We set this entire file up for you now, do a lot of identification, and this all gets exposed in our app creator. So it just saves you a ton of work, right? And you can actually customize this if you want, but really you shouldn't have to. So that leads me to the XDK, and we're pretty excited about this product. It's under heavy development. We've got about 25 engineers working on it full time. Bugs get fixed daily. Our whole goal is to write once and deploy anywhere. We really want to enable people to develop their apps, and get to market faster. We want them to be able to target any device and be able to use accelerated libraries, things like that. And we have on our website tons of tutorials, and we hope we've laid it out in a totally simplified workflow. So there's some new cool things in there. We've updated to the latest PhoneGap library, or Cordova libraries, which is what PhoneGap rolls up and takes. We have an app designer, it's a GUI app designer, and then we have also included brackets as our primary code editor. So it's an HTML5 editor, cool plugins you can add, whatnot. And then we've also done something under the test thing, which is an app preview, and we have this app previewer that you can get from the App Store, and then you can quickly debug on your phone without having to actually install the app. Can you see that? So, really hard to read. Basically what it says is design, emulate, test across the top there, and it's pretty logical the way it goes. I encourage you all to check it out. The brackets, we already kind of talked about that. Syntax highlighting. So the App Designer UI, which I'll give you guys a demo here in a little bit, it is really pretty cool. So you have all kinds of widgets on the left, buttons, pull-down lists, like progress bars, things like that, all completely automated. And you can switch between GUI and code and make changes in either, and it's round trip. And I think it's the only tool I know so far that will allow you to do round trip editing on both sides of the project without making anything. And then app preview is, I think I already talked about this. So you download this thing, and it's a container application that sits on your phone. So what this does is allows you to do pretty much everything your application can do, but it lives inside a container, so it can't really hurt your phone. And you can continuously make changes. You can iterate between, code and design and whatnot, and just keep scanning, keep loading the web link, and it'll push down to your phone, and you can make all of your updates. And once you're finally happy, then you can actually build it, a mobile app or a web app. And we have all of these, this is our cloud build service, completely free also. And you can target all of these platforms. You, of course, need to have your developer keys and IDs loaded up. And it actually tells you if you're missing icons and metadata so that you have a successful package for the App Store, which I find really helpful because it's pretty confusing, all of the pieces you need to submit to an App Store. It does everything but submit it to the App Store for you, which is very, very cool. So I think we're doing really good on time. I wanted to give you guys an actual demo of the little project working here. And see if you can bear with me here, if the demo gods don't dislike me today. Okay, so here's, wow, you can't see that at all. Here's my project. It's just called Arduino demo. Gauges relies on Raphael, by the way. I forgot to mention that, which is actually a really cool graphic library. One of the custom, so this is the entire thing that gets generated by the app designer, and everything else kind of goes into CSS and JavaScript. One of the things we really needed to, custom thing I really needed to do was basically this section here. Can you even read that? Sorry. Hang on, let me find it here. Had to do with orientation of the device, and basically some are 0, 90, negative 90, and 180. Or 0 and negative 0, depending on the device. So as you rotate the device around, you need to find out whether you're in landscape or portrait mode. And basically, I just figured that out, added some padding, and you kind of had to work with gauge.js because it basically was looking at the entire window, and so you had to figure that out. So you will have to add some custom little section to your code depending on your mobile devices that you're targeting and what the application actually is doing. So what's really cool about the XDK now is, so you've got this, and then, oh my gosh, there's no screen space. Here's the widget I was talking about, and if you go down to widgets, you can see we've got accordion, and there's the JustGage widget, which
oh, that's so funny.
So you can see we've exposed a ton of the variables for JustGage, human readable values. You can change your initial value to like 221 or 200, whatever, and it just depends on what you want to do. And set it up. You could have I could add more. Oh my gosh, you can't even see what I'm doing. Sorry about that. I can't remember the last time I had a 1024 by 768 screen here. You know, and it's just as easy, like if I wanted to add, let's say, my barometer sensor here, if that ever showed up, you can see I have a new gauge, and so you could call it, you know, barometer. You know, give it it has its own ID. And what's also very cool, I don't know if you guys can see this, there's these wrap points up here. And what this does is, depending on your orientation, the UX automatically does the wrapping for you. So as you move these triangles around right here, you can take them away and set them depending on what you want. And you can have multiple wrap points if you want, if you have 3 columns or 2 columns or 4 columns, which is really very cool. And that's all done for you. If you look in the CSS, it's all done. You can see the extra divs down below that allows you to do that. And it saves you a lot of work. It really does. So here it is under emulation. You know, I'm going to get rid of things, and you can see it kind of emulating there. And if you rotate it, you can see that it's being responsive. So it's actually going in portrait mode and then doubling wide for column. And you can choose multiple devices, you know, like you do with Nexus 4. And it looks terrible. I'm sorry. That normally looks really great. And you can check on like a tablet, for instance, even though that's not even going to fit. And you can see that, you know, it lines up nicely. So I was telling you guys about the test service. And all you do is you scan this QR code, and you can continuously emulate between develop, emulate, and test, and continuously update your things there. And then ultimately you can do build. So it's really useful. Okay, so I think lastly I want to show you guys is this thing actually working. And so I can go to oops. Node server. So that's going to start the node server. And then you can see it's parsing the JSON right there, right? So it's actually spitting out. That means it's working, which is a bonus. Now you can, what I forgot to mention, what's kind of cool with the XDK is you can kind of go backwards. You can build your mobile app first, take your index.html, and set that as your web app. So, you know, you design your UX and what you want things to look like, and then you can go and there it is in a web, right? And it's responsive, scrunches down, comes to 4 columns, moves around. And then here we go. Let's see if I can get my Galaxy tab to do this right. We'll launch it, and then there we go. See? And it's updating from your Arduino, and as you rotate it, it resizes correctly. You can rotate it any direction. It always behaves. And if you blow on the CO2 sensor, you can see that go way up. Or you can do the light sensor, and that cranks way up. See? And it's really responsive, fast. Anyways. Yeah. Well, so, you know, it's interesting. The good level is supposed to, outside's about 400 parts per million. Indoor should be around 600. Less than 600 is better. Our office is typically anywhere from 13 to 1,500, which anything over 1,000, they say you start having smells and grogginess. So this is kind of proving my point that they're not pumping enough fresh air into the building, which all this stale air and people coughing and sneezing is why we all go down and get sick at the exact same time. So I pretty much proved my hypothesis, and if there's any questions, we've got plenty of time to take those. Yeah?
I wonder if you've considered moving the Galileo board.
So I knew that was going to come up. I got my Galileo board Tuesday last week, and yes, but it won't be a challenge. I mean, it's got a 0.5 gig of RAM. It's got an Ethernet card that doesn't share. So one of the problems with the Ethernet card is it uses several pins that write to like an SD card for memory. And so you can only do one at a time. You're either listening to your Ethernet connection or you're writing to a SD card, which is on it, which really kind of hiccups your application. But yeah, the Galileo, I just got it. I was afraid to move everything. But yeah, that's my next project, and I want to throw about 8 more sensors on here to do that. So yeah, the other cool thing is I have a friend that's doing the 3D model for my case, and it's going to look like a little droid helmet. So it's gonna, yeah. Any other questions? Oh, you guys are so quiet. It's awesome. What's my next project? Yeah, so we have an internal Intel makers group, and I want to scale this out all throughout the building, so you can and actually do this in a native Android format. Because one of the issues I noticed, and I've actually filed a bug on this, full disclosure here, is that it's only about 200K of code that I wrote, but once you actually package it up and make a hybrid application, it balloons out to about 10 megs, which that's why I kind of had this pre-prep for you guys, because it takes about 15 seconds to load, which I find totally unacceptable. Yeah, so, but it looks good. It's pretty. Yes? Absolutely. You can definitely do WebSockets go 2 ways. Like if I had a servo or LED lights, yeah, you can easily push both directions. This is I went out, not in. Yeah. I tried that, doing Arduino, and I have so many sensors I ran out of memory. Yeah, and that was the point I was talking about. Like, you can put a bunch of this stuff on the SD card, on the Ethernet shield, but then you really got this like initialization delay while you send a pin high, send a pin low to write to export out of each device. And I wanted a more responsive app. So pin 10 is what? Oh yeah, but Galileo has Ethernet off to, it's like it competes more with Raspberry Pi than it does with this, although it's Shield compatible with Arduino, which has way more things for it. Yeah. It's a cool product. I think the first 50,000 went to Italian kids. I got lucky because I was in the Intel makers group that no one else has them yet. They're not supposed to be out till November sometime. Yeah. This will all be up on the Intel Developer Zone. I'll open source all of this once I pass our IP scan. It's big company stuff, right? And you can get all of these all of the tools, the App Porter tool and the XDK for free at software.intel.com. And that's me. If you have any more questions you think about in the future, yeah. You're actually doing it. You're actually doing it in the Arduino IDE, which is this awesome little thing that looks like, a 1995 IDE. It's full on type it out, and then you do this thing right here where you hit verify, and it compiles your sketch. And what it does is it spits out that this is like a test sketch that you've used 24 of the 32,000 bytes, and you've got 7% of programming space, and you've got a kilobyte for variables. So you basically always verify your sketch while you're doing it, and see what you can pull out to squish it all in there.
So you just sort of add one sensor design.
Yeah. Well, and then you look at the reference libraries, and you take as little out of them as you possibly can. Like they have all this error code checking and massive output. Get rid of all of that. Just grab what you want. Look in the .h file. If they're using something like the lumen sensor does infrared as well as visual light. Well, I don't care about infrared. I'm indoors, so cut all that out of the include file and save yourself, a few hundred bytes. It really is that manual. I wish it wasn't, but it is. Yeah. 32K. It was fun. It was a challenge, right? How much can you cram in there? But definitely don't go up to the edge because it gets unstable, or at least in my situation. And that just might be like variables growing and things like that. Yeah. Any other questions? Well, thank you for your time. Enjoy the show. We're super excited to be here. Stop by our booth, learn about all the other stuff we're doing at Intel, and thank you.